Alright, so here's the Wireshark project I wanted to demonstrate to you. I've used this in other classes, and this is sort of an introduction to networking. You get a lot more of this if you take the 106 Network Plus course or the Cisco classes. But this is the beginning. So you first install Wireshark. You don't need a virtual machine or anything. You can install Wireshark on any operating system. So it's running on my Mac right here. Okay, so you can capture live traffic with Wireshark, but that's not really the recommended way to use it. The recommended way to use it is to analyze traffic that was captured with other tools like TCP dump. So here you download this file, and there it is. I'll just put it in my downloads folder, and sure, I'll replace it. All right, and when you double click that, it will open in Wireshark if you have Wireshark installed, and then you'll see a 296 packets, it tells you down here. And so I've got some traffic. Now, the first thing you can do with Wireshark is just look at packets one by one, and we'll use other techniques. But the first thing is just notice what you've got here is a TCP handshake. You send a SYN from local port 50690 to remote port 443. Then the server sends back a SYN ACK. Then your local machine sends an ACK. That's the TCP handshake that has to happen before every transmission. And I see my head kind of in the way. Let me move that over. Yeah, so it's a SYN ACK, and an ACK is the TCP handshake. So let me check my instructions here. I'm going to move them to the side. All right. So that looks pretty good. All right, the packet list shows the packets. We have the TCP handshake we just looked at for 443. If you take, say, the SYN packet here that started that, if you go to the middle pane, you can see the detailed layers. Like I said before, this is layer 1, just telling you how many bits went down the wire. Then layer 2 showing you the MAC addresses. Layer 3 showing you the IP addresses. And layer 4 showing you the port numbers. All right, so now we're going to use FTP, so you can filter this thing for FTP. File Transfer Protocol, an old protocol that dates from the times when people didn't think about security very much on the internet. And let me make this a little narrower so it'd fit on the recording better. All right, so here you see, let me keep making things a little more to the left. There, I think that's working better. All right, so I don't really need the middle pane for what we're doing right now. So right here you can see a summary of the packets. So here's connecting to a server with the version of FTP software. Please log in with username and password. And here it sends the username, John, and here it sends the password. So you can just see in this summary line a quick summary of what's happening with FTP. So it's easy enough to just see, as you can see, FTP passwords are sent in plain text, and they just appear right here in the summary pane, so they're very easy to spot. HTTP, if you don't use HTTPS, but you use HTTP, then it has a similar flaw. So there's another file to download here. I'll download this thing, save it in downloads, and open it in Wireshark. All right, and the reason I don't see anything is I left the FTP filter in, and this packet capture does not contain any FTP traffic. So here, let's filter it for HTTP. Every time you catch traffic, you'll get all kinds of extra stuff like ARP and NTP, because there's a lot of different traffic floating around on your network. And so you often have to filter to get the traffic you want. And this time I want HTTP traffic. So here I am going to some web page, get a 200 OK. Then it gets the fave icon, which is just a little graphics that appears on web pages. And then it sent a login, and I got a response to the login. So I did a login here over an unencrypted protocol, but you don't see the password right here the way you do in FTP. It's in the traffic, but the Wireshark program doesn't bother to put that much in detailed information here. So the way to do it is to find the post to the login. Generally, a GET is what you use to view a web page, and a post is what you use to send data up like a password. So if you click on one of the posts, you can then go to the details pane, and if you go to, here's layers 1, 2, 3, and 4, And above that is Hypertext Transfer Protocol, which is what's used here. And if you go down here, it will show you all the data that was sent. And that shows you the HTTP header, but the actual data, I think, is down here. Yeah, here's the data, username and password, and submit. So you expand these layers, and you can, again, the password is there, but you have to expand a few things in the middle pane to see it. So another thing that's good is to do follow TCP stream. So if I go to the info and I right-click this post, any packet in the HTTP stream will do. I can then do follow TCP stream. And this is very handy. Now you get all the data sent to the server in a nice readable way with no addresses or anything. So this is what was sent to the server. Post login.php, a bunch of header fields, and down here u equals Isaac and p equals flapper and canvas equals submit. The red is what I sent to the server, what the user sent to the server, and the blue is what the server sent back. So this is a very useful trick, and you can move through the streams with this button here. So there was a TCP stream before this one. Not letting me switch though. There's a 3 one after this one, another login, and another. So there were 3 streams visible here. And you can go between either stream 1. There was a stream before this too. Yeah, there was a stream that loaded the page with the login form. Anyway, so that's often a handy trick. By the way, one thing to notice, if I go back to that login stream, you can see the username and password being sent, but the page that comes back is zipped. Because up here, it had this header, content encoding gzip. Then it's allowed to send compressed data from the server, and this is very commonly done to make the internet move faster. So this junk here is compressed data. You'd have to unzip it to see what's there, and that's the HTML code that made up a page. All right. And so there's a couple more things to see there. One thing worth mentioning, there's some challenges here like basic authentication. I guess I'll demonstrate that one. And then, so let me get this one downloaded. All right, here's one with basic authentication. Let's get rid of this. All right, and get rid of that filter. All right, here's all my data. So this one here is again using HTTP, so I'll filter for HTTP. All right, and so now this is what happens with an old-fashioned system called basic authentication, which was intended to be more secure than the kind of login that we just went through, although it's not that secure. So you get a page called secret index, you get a reply saying unauthorized, then you get it again. Now when you get the reply that says unauthorized, a little box will pop up in your browser asking for username and password. And when you put it in, it will send another request, which is then approved. So let's take a look at the difference here. Here's a GET request. If we go down here and look at it, in fact, maybe following TCP stream is the easiest way to see this. All right. I don't think there's a way to make this font bigger, which is kind of annoying. But anyway, so here I send a GET, and it tells me I'm unauthorized, and it sends me a whole page back to view. So that was the first thing that happened, and now it's going to pop up a box and ask for a name and password. And the next time I send a GET again, now it's going to let me in. And the reason it's going to let me in, notice this authorization header up here. Authorization basic followed by a bunch of random letters. The first request, if I go back, did not have that. So that information there is the authorization that was constructed from the username and password, and that's why it let me in. That's called basic authentication, and all it does is it takes username :password and encodes it with base 64. So it's not very well hidden. You can't easily read it, but Wireshark will in fact unpack it for you. So if you go to the GET, which is going to succeed, let me just go back from this TCP stream filter to HTTP. This GET doesn't have any authorization in it. If you go down here and look at it, the authorization is not there. But this GET has it. There's the authorization. And if you just expand this, it will tell you what it was. Waldo very secure. So Wireshark includes unpacking this from base 64. You could use web pages or Python to do it too, but it is included in Wireshark. All right. And there's another challenge here, all for extra credit, which I got from a CTF called APT Capture. And I don't think I'll demonstrate this one live because it'll only be for the students that want to do the more advanced stuff to do it. But this was fun. You have a big file with, this was for the Red Team CTF a couple of years ago. There's an encrypted transmission. There's an encryption tool used. You can see the command line executed by the attacker, and you can find out what tool they used to encrypt the data. They even downloaded the data over the network. You can recover the data and get the hash of the tool. And you can even find the key, which was also transmitted over the network, and decrypt the data. So it's kind of fun for people that are ready to try some more advanced Wireshark challenges. So that's it for that demo.